Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 7.3, the Pythagorean Theorem. And it can be found on pages 302 to 303. Okay. So what are the nuts and bolts of the Pythagorean theorem? Well, the Pythagorean theorem only applies to right triangles. So the Pythagorean theorem only works with right triangles. Okay? So it only works with right triangles. So let's talk about right triangles. What is a right triangle? Well, a right triangle is a triangle that has a right angle, a 90-degree angle. And the way we label the sides is very important for the Pythagorean theorem. We need to know that the two sides that make the right angle are called legs. So this is leg A, and this is leg B. And we need to know that it is the two sides that make up the right angle are the legs, A and B. The side that is across from the right angle, this is called the hypotenuse. And it's always referred to as C, okay? So we need to remember that the legs are always A and B, and the hypotenuse is always C. Why do we need to know that? Well, because the Pythagorean theorem says A squared plus B squared is equal to C squared. And we can't get these all mixed up. It's a leg squared plus the other leg squared is equal to the hypotenuse squared. This is the Pythagorean theorem. So what does that mean? What does this mean? Well, let's take a look. Here's our triangle, and we already said this is A, B, and the hypotenuse is C. Okay, but what does it mean A squared plus B squared equals C squared? Well, we're going to take A and we're going to square it. So this is now A times A. We made it a square. We're going to take B and we're going to square it. So this is now B times B. So B squared and A squared. Now, if we take the area of A plus the area of B squared, so we take these two areas and we add them together, and it will be equal to the area of C squared. So this is C times C, which is C squared. So the area of A squared plus the area of B squared, when you add them together, it equals the area of C squared. So let me give you an example of that. Let me give you an example. We have our triangle. A is 3 units, B is 4 units, and C is 5 units. Okay? let me show you how the Pythagorean theorem works. So this is 3 units, and we're going to square it. 3 times 3. So 3 times 3 equals 9. This is 4 units, and we're going to square it. So 4 times 4 is equal to 16. Now, if we add 9 plus 16, a squared plus b squared, we will get c squared. So 9 plus 16 equals 25. So this whole thing is 25. C squared is equal to 25. But we don't want to know what the area is. We want to know what just the edge is. So if I square root this and I square root this, C is equal to 5. So this is what we're doing. And I've got a video. I've got a video that I want to show you that will explain this. It's a nice visual. So let's take a look. So this is a squared and b squared. So if we take the area of a squared plus b squared, it is equal to the area of c squared. So if we take the area of c squared and we break it down, it is equal to the area of a squared plus b squared. So I think that's a pretty nice visual representation. So let's go back and do some examples. Okay. So there's 2 different situations. There's 2 different scenarios. In the first scenario, the measurement or the length of each leg is given. So in this case, the 2 legs are given. The measurement or the length of each leg is given. So here we have 5 meters and we have 12 meters, and these are the legs because each side forms the right angle. And we're trying to find C, the hypotenuse. The hypotenuse is across from the right angle. So we know a squared plus b squared equals c squared. So now it's substitution. 5 squared plus 12 squared equals c squared. 5 times 5 is 25. 12 times 12 is 144. And we still have c squared. So let's add these together. 25 plus 144 is 169. And that's what equals c squared. Now, we don't want c squared. We don't want the area of c. We want just the length of c. We only want one of these guys. So we're going to take the square root of c, and what we do to the one side, we must do to the other. So what this is telling me, the square root and the square cancel each other, or this is c times c, and I want only one of them. Here, 169 is 13 times 13, and I want only one of them. So 13 is equal to c. C is equal to 13 meters. So in that case, we were able to square both of the legs, add them together, and then take the square root to find the length of the hypotenuse, C. Now, there is another situation where only one leg and the hypotenuse are given. Hypotenuse are given. So in this case, we have a triangle, a right triangle, and here they're telling me that this leg is 16 yards, the hypotenuse is 34 yards, and we need to find the length of this leg. So I'm going to use the same formula. A squared plus B squared equals C squared, and it's substitution. 16 squared plus B squared is equal to 34 squared. And I'm going to use a calculator. 16 times 16 is 256 plus B squared equals 34 times 34 is 1,156. Now, I need to isolate my variable, and this is back to basic algebra. I need to isolate my variable. So I need to get rid of this 256. I'm going to subtract it. What I do to one side, I must do to the other. So I'm left with B squared equals 900. But I don't want the area, I don't want the square area of B. I want just the length. So I'm going to square root. Take the square root of B squared. What I do to one side, I must do to the other. So the square root and the square cancel each other, or this is B times B, and I want only one of them. Here, 900, you can use your calculator, but I know the square root, I know 900 is 30 times 30. So I want just one of those. So B is equal to 30 yards. So B is equal to 30 yards. So that's it for this lesson. That is the nuts and bolts of this lesson. You're going to be given right triangles, and in some cases, the length of the two legs will be given, and you have to find the hypotenuse, or C. And in other cases, they're going to give you the length of one leg and the hypotenuse, and you have to find the length of the other leg. Now, something that you might also find helpful, and it is attached to the agenda, is this anchor chart. This anchor chart is showing you that the leg A squared plus the leg B squared, put all those square units together, and it is equal to C squared, okay? Here's an example of two legs given with a missing hypotenuse, and here's an example of a leg and a hypotenuse given with a missing leg, okay? So you might find this anchor chart helpful as well. Okay, so that's what we're doing today.